All right, next we're going to talk about Charlie Coulomb, but first my son has come down to make some copies, and he would like to say hi.
Hello!
I don't know how loud that was because he about ate the microphone. Anything else you'd like to say?
That's from over 10 years ago.
I believe he said that's from Horton Hears a Who, which is my least favorite movie ever. And you guys are going to think I'm crazy because my wife laughs at me too. I hate the kangaroo lady. She is the meanest villain ever. I would rather hang out with Hannibal Lecter than the kangaroo lady. She's the meanest, most unreasonable person ever. Anyway, so I can't stand watching that show because she's so bad. That's kind of ridiculous, but anyway, I'm sure you care. Anything else there?
No.
All right, thank you very much. You may continue. All right, so let's talk about Charlie Coulomb. Thanks for your patience. All right, he showed the, I believe it's relationship, but if not, oh well, it'll work. Between the amount of electrical force that two charged particles exert on each other and the distance separating them. Okay, so this gets a little tricky. The first couple of things that we watched were just on two people that had basic ideas about the model of the atom. From here on out, we're going to talk about parts that people put together to come up with the model of the atom. So Coulomb didn't necessarily have his own model, but he provided some information that's going to lead to more detailed versions of our atom. Hold on, my son's having a cow. All right, disaster averted. Okay, so Coulomb comes along, and he comes up with this Coulomb's law. You watched in the video that when certain things were rubbed, like cat or rabbit fur with something like a rubber or a glass rod, it would become charged. Coulomb studied these charges, and you saw it in the video. All right, Coulomb came up with his law that said that the force due to electrostatic things was equal to a constant, K, and then Q1, Q2 over the distance squared. All right, so what K is, it's just some constant number that's equal to 9 times 10 to the 9th, if I remember right. All right, now Q, we don't really care about things if they're constant, but we care about what Q is. Q1 is the charge of one thing. Q2 is the charge of the other. All right, so for instance, oh well, let's talk about D. D is the distance between them. All right, so if I take a positive charge and another positive charge, it's going to be a +1, another +1. My force is going to be equal to K, which I don't care. 1 times 1 is 1 over D squared. All right, now what I do care about is if I have two positive charges multiplied by each other, my force equals a positive value. A positive value means that they repel or they push. All right, he's going to come up with the law of attraction and repulsion, and that's that opposites attract and likes repel. If I put in opposites here, I'd have a +1 and times a -1, and that would mean my force would equal a -1 value over D squared. If I have a negative charge, that means they attract. So that's where we get this. All right, and then on the bottom, as the distance increases, the electrostatic force, well, that's huge, decreases. So that's this bottom part. If I increase it, it decreases by a square, so it decreases a lot.